Recording started. Okay. All right. Welcome, everybody. I'm Knut Oxnevad. I'm the president of the Norway California Business Association. And I'd like to welcome everybody, and especially Trengreid, who's like counselor of science, technology, and higher education at the Norwegian Embassy. And I think I might also have some of my board members on, which would be Francis Mohadjirin and Homayong Moragabi. And welcome to everybody else. And what I'd like to ask you to do first before we start, this is a webinar that reaches across the globe. Many of these have. And I encourage you to use the little chat bubble and just type in where you're from, and we'll go through that after we've gone through here a little bit, a few items before we get there. But if you can do that, it would just make this even more exciting and interesting for everybody. Let's see. NCBA, Norway California Business Association. We are an organization that caters to and initiates and encourages collaboration between Norway, organizations in Norway, and organizations in California and the US. We have a very strong relationship with JPL and NASA. We try to focus in on areas that are especially interesting to both Norway and California, such as sustainability, ocean, etc. And when you talk about ocean, the topic of this series of webinars we are going through, the last one, is ocean worlds out in space. And to us, that's a very important topic, and there's a lot of collaboration opportunities. We're already seeing potential for collaboration between SINTEF and JPL, and we expect to see more of that coming. Let's see, yes. So with that, I like to go to the chat here and see where people are from. I want to make this very short so we can get to the talk. I got a gentleman from Kevan, I guess that is that he or she, but anyway, Thailand. Thank you. We got Israel, we got Honolulu, Hawaii, we got France, we got California, we got Norway so far, and I'm sure we're going to have more here. Oh, wow, a lot of stuff here. Let's see, Princeton, New Jersey. Okay, Hunky Man. Okay, that was Thailand. Welcome. And let's see, Portugal. We have Norway again. So anyway, welcome everybody. Very excited to have you on board, and hope you will enjoy this webinar. So with that, let's see any more. Yeah, I think this gives us a very good understanding about the need we're having here. Okay, logistics. I'd like to do this is we have, of course, let's see, I'm going to mute everybody so we don't have any issues there. Let's see, here we go. I'm muted. Oh, there we go. Okay. Logistics. The speaker, Peter Haro, I'm going to introduce him in a second. He will give a talk, and you're welcome to write your questions as the talk goes on in the chat bubble. You're also most welcome to ask questions in the Q&A afterwards. And we encourage you to come up and ask your questions during that time. So even if you write it in, we'll have you ask the question. And when you do, please feel free to put on your video, and you're more than welcome to do that for everybody during the Q&A session. So that was that one. And yes, Peter Haro, he's our speaker today. So let me say a few words about Peter. He is a researcher, and let me see, let's go here again. There we go, there you have it. He's a researcher and the principal developer at SINTEF Nord, that is in Tromsø. He has a background in big data analysis, machine learning, and decision support systems for multiple domains. He has worked with safety critical applications and communication protocol systems for real-time systems in aviation and robotics. for autonomous systems and hydroacoustic mapping. Very accomplished, good friend of mine, and we're very excited to have him here. With that, I'm going to leave the floor to you, Peter, and I'm going to make you the presenter. Let's see if we can find you. Here we are. And then we should be ready to go for the races.
All right. Thank you for the intro.
Let's see. Here we go. And you're ready. Okay.
All right. So let's see if this works.
Yeah.
Hopefully you're able to see the PowerPoint now. Okay. So I'll just start, I think.
Yep.
So as Kenneth said, there are interesting topics with regards to exploring the ocean worlds in outer space. I will talk about controlling the seas here on Earth and infrastructure and robotics for exploring these ocean worlds. So before I start the presentation, I'd just like to preface that I will talk about both technology from SINTEF and outside of SINTEF. And in that regards, I'm in no way representing the other companies. So I'm just representing SINTEF and basically myself here. All right. So SINTEF is a research organization that is a non-profit, and it's one of Europe's largest independent organizations. And the unique thing about SINTEF is that compared to many other research organizations is that our revenue is obtained through competitive tenders. Unlike other institutes in Europe, we're only about 8% base financed. Okay, so with that, I will start the presentation. Thank you. Okay, so as probably many of you know, but I should say that Norway is a very small country with a comparatively large amount of ocean access, right? The country has been seafaring for as long as people have lived here, and we have a very strong maritime tradition. And the discovery of oil and gas on the Norwegian continental shelf in the 1960s accelerated the need for subsea technology and competence, and for many years formed the most important driver in the evolution of the subsea tech here within both the public and in the private sector. Due to the fact that all the findings on the continental shelf belonged to the government, the competence and technology developed with regards to these findings were then kept here, and we were able to iterate on those as we discovered further and further oil findings outside where we started. And many of these places where the platform are built, the oil has to be transported to land in very harsh, complex environments. So this advanced the pipeline technology, and once you have hundreds or thousands of kilometers of pipes subsea, you need some way to inspect them. And you're now in very hard to reach places, both in the platforms, the pipes, and other things you need to transport. And it's costly to transport this. It's dangerous for humans. So we've been developing ROVs, AUVs, and USVs for many of these operations simply to reduce the risk and the human cost. And the robotics to do this operation have very strong synergy done with the research on hydroacoustics, because as I said, Norway is a pretty small country with a large amount of sea. And before oil and gas findings, we were basically all just fishermen. For as long back as my family line runs, I think almost 500 years, every single male has either died trying to find fish or died trying to go home from finding fish. So fish finding technologies such as echo sounders, sonars has played a huge part in the modernization of the fishing fleet, but have also played a huge part in the robots that are used for sensing, for doing mission-based autonomous operations. And once you're starting to, so once you're starting to implement or instrument, I should say, robots with a complex sensor suite, which might be multifaceted for vision, sensing, or intelligence, you start facing a multitude of problems, right? Because for a single, can you guys see my mouse, by the way? It's quite important for this part.
Yes.
Okay, yeah. So let's take just a simple echo sounder, right? You start facing problems with regards to a false seabed due to the fact that the signal is processed differently compared to what type of surface, what type of impurities, what type of salinity, right? You can see that there's a seabed underneath the real seabed here, which a human can see using experience. You have also all this noise coming into the picture, which can come when you have crosstalk. So let's say you have a sonar, as on the vessel here, you have an echo and a multi-beam echo here. All of these devices can interfere with each other. And they say that for fishermen, it takes 20 years of experience to learn how to use this. And that type of intelligence is very hard to model sufficiently mathematically. So we can easily model an echo alone, but once you start combining them, and once the vessel is moving, you have all this temporal lag, which interferes, and you have the crosstalk, and then all of these issues compound. And once you start to implement robots with sufficiently advanced sensorship, we don't have the capabilities of modeling it. And then for one trip, we generate about 12.5 petabytes of data, which also is in energy constrained environments very hard to do stuff about. So we're seeing that we're moving towards a more data analytical approach to this. So I will show you some examples of highly instrumented UAVs, and we'll start with Hugin. And Hugin is has a pretty long type of development. It started in 1995 with Kongsberg Maritime, FFI, and other organizations in Norway. And it has gone on for since then. It's been continuously under development. SINTEF and many other research organizations have a part in this. And the thing about Hugin is it is made for emphasis on the long endurance mission because it has to be in harsh operations in the North Sea. And they have to map the bathymetry there. They have to have a very high coverage rate, and they use a synthetic aperture sonar. And due to the fact that the environments that they're working in is pretty hard and it's hard to retrieve them, they have to function correctly, right? And once you have, as I mentioned, multiple devices on board, you start facing problems with the data here. So one of the problems that we're facing today here is no longer in the engineering of the vessels themselves. It's about understanding the data correctly. So for instance, here you can see a torpedo with about 20 × 20 resolution at 90 meters range. And once you're combining that with other sort of sensors, you move into something that was very popular 10 years ago, the sensor fusion term. For instance, here to do SWOT bathymetry mapping, you have to combine multiple sensors such as sonar, such as multi-beam echo and a synthetic aperture sonar. And once you start building upon what you can do here, you're able to do pretty sophisticated operations. For instance, here you have a SWOT bathymetry mapping of the hydroacoustic Lange effect in order to see how the bathymetry is, so you can build stuff. It's quite interesting. And once you start getting this sensor suite up, you start to be able to actually utilize the data. You can do more complex operations, such as doing under ice survey operations. So, for instance, today or before, you used conventional seabed mapping with icebreakers, which is a very time-consuming task. It's very challenging to run straight lines because the icebreaker has to navigate through ice. And once you hit ice, you have the multi-beam echo sounder. It has very different propagation. So it propagates very differently in ice and water. So you start getting inaccuracy in the data. It's very hard to utilize the data then. So what you can do here is you can have an AUV which can contribute by accurately following planned survey lines because it's underneath the ice. You can have increased mapping efficiently because, again, you're just in water. This allows you to have increased data quality, increased mapping resolution, while simultaneously recording a full geophysical sensor suite and oceanographic data. And the thing here is you can combine it with the icebreaker. You can use the icebreaker as a platform, and then you can need novel technology for penetrating ice here. You can use, for instance, RF on the AUV, and if you can use the RF through ice, which you can today, you can send out simply for recovery missions a unmanned flying device such as a drone or other, which can use the RF to localize the AUV underwater. So this is a quite sophisticated place where where AUVs function, right? And we can see here on the image that is taken underneath the ice, where you can see a submarine wreck for about 245 meters away, and you're able, for at 320 meters, it's here, it's a 1.1 meter cube. So we're seeing that the AUVs are very sophisticated. They are able to do things that 30 years ago were absolutely not possible. But the problem with AUVs, or I shouldn't say AUVs, the torpedo-shaped AUVs such as Hugin, is that there are many places they cannot go because they're torpedo-shaped, right? So today we're seeing there's a lot of new technology coming up with regards to swimming snake robots. And swimming snake robots, it can serve a different purpose. They have a lot of different subsea applications that the traditional torpedo-shaped UAVs cannot do, because there is an increasing need for underwater vehicles in different areas. As we see here, for instance, subsea operations are often conducted in dirty, dangerous, distant, and dull environments. And further installations are deeper, more remote, and probably eventually under the Arctic ice. And if you want to do maintenance there, it is highly difficult. So if we're talking about the next generation intervention UAVs, we often talk about snake robots here, because they are characterized by a very high number of degrees of freedom. They are very slender and flexible, as you can see in the video here. This gives them the superior access capabilities, and that makes them very useful for tasks in the challenging environments they can do, but are not limited to underwater monitoring, inspection and intervention of complex oil installation, and many other marine tasks. And these bio-inspired swimming robots can be used for several applications. Since they're flexible, they can operate in these environments I just mentioned, and they have a head module at the tip, which have intervention tools or other sensors to do light intervention tasks. Or they can have cameras, which allows them to do inspection capabilities. And the overall goal is to have permanently installed a swarm of snake robots ready for intervention and inspection tasks in the future, right? So I know a lot of guys are interested in the Illume snake robot, which is a very sophisticated snake robot with a payload interface, as you can see here, with multiple different tools. And they don't only have a torque-based joint module, they also have these thruster modules, which allows them to have a very high degree of freedom in water. So here is a actual video of the Illume snake robot. And Illume was established in 2015. It was a spin-off from the Norwegian University of Science and Technology, NTNU. And after about a decade of research on snake robots in collaboration with the research institute SINTEF, they decided to pursue, I should say, industrial subsea applications on the platform. So they're able to inspect the different subsea structures using their camera on the head. We can jump a bit. Hope it's not lagging for you guys. And the same can do for chains, mooring. And let's just skip ahead. And what they also can do is they can torque on the different valves. So that means that a snake robot can be permanently situated underwater. They can attach themselves, they can recharge themselves, and they can also torque a valve. So they can adjust things and parameters underwater, which gives us novel opportunities compared to traditional AUVs. So this is the detaching, it's pretty cool. So when we talk about Illume, they often talk about the Ilium Concept. So Illume, in a way, resides between the area of AUVs and ROVs. For ROVs also have, of course, intervention capabilities, but they are human controlled. You have to control them yourself. While AUVs, of course, are autonomous, but they seldom have the capabilities of these sophisticated snake robots. So they place themselves in this. These slides will be available. There's no point in me just reading everything that it says here. But yeah, so this is the takeaway here, I think, is that they place themselves in this. And to demonstrate this, there's an ongoing research project where they plan to pilot 2 autonomous Eelume robots at the Åsgård oil field in Q4 2021. And here they will be as the subsea resident robots. They will have their own docking station, so they can do autonomous near template inspection. They can adjust valves as see fit, and they can do pipeline inspection. And pipeline inspection is a very important thing. And with torpedo-based, you have to have all this sensor suite going over the pipes, trying to analyze them. And if you see something that it's very hard to get the torpedo in a way to twist and maneuver to see whether or not it's a real fault, but with the snake robot, it's very easy to just, in a way, bend the head and see. So if everything works here, it will prove their relevance, and the project will start with the commercial rollout. So it is, we'll see at the Q4 of this year how well it goes. So when you're building these next generation AUVs or ROVs or everything I've spoken about, want to test any hydroacoustic or other types of acoustic sensors, you need some sort of lab. And when you're trying to build novel technology here, it's very difficult to get the through the I should say from modeling to real life, right? You often do these field tests, such as you see here, which might be where things will operate in real life and where it might not. So to support this, there's a huge ongoing initiative called Ocean Space Center. And Ocean Space Center has this huge vision, as you probably can see here, is to build a super cluster of technology to support all these marine industries. So although it's a huge project, and I will get back to some of the parts, I want to talk about a couple of new labs being built here because they're quite interesting. So we have so I've translated from Norwegian to English, so we'll see how well it goes. This is called Havbassenget, or as I call it, the ocean pool. It's a 60 times 50 times 20 meter pool with a center hole, as you see here, which is 7.5 times 10 meter. So what's interesting here is they have multi-flap machines with active suspension among two sides for directional control. So you can control the waves however you see fit. You can move the waves to collide exactly where you want and how you want, at what speed. And when you combine this with an integrated system for wind and current generation, you're able to pretty accurately simulate real-life conditions. And then you have, as you see here, what's called the ship ocean floor. And although this pool is smaller and shallower, or I should say more narrow and shallower than the current SINTEF ocean pool, it provides very new functionality, such as raised lower floor, more instrumented with newer sensor packages, etc. And this lab, as the Havbassenget, is intended for near field testing, verification, certification, and studies for autonomous and unmanned ships, because they need larger areas for testing, and they want to test the interaction between autonomous and non-autonomous crafts. And as I've written here for both of them, they have something called the integrated interface toward hybrid testing. And the hybrid testing framework is quite interesting because it's a combination of experiments in lab, computer simulation, and real-time testing by active control system. So you're able to use the hardware that you would normally use to test, and then you can mathematically model the things that you cannot test. And you do this, of course, to compensate for lacking infrastructure. Cannot test everything, especially pool depth, for instance. And for things that we cannot physically accurately generate, for instance, a polar low is very hard to generate in the lab. You can model that while testing the other things in real life and combine those to see. And this, of course, is very cheap for parametric tests compared to real life testing. But once you move out to the lab, you want to move into the real world. So that is where ocean labs come in. An ocean lab, it's actually been expanded upon this slide. Now there's 4 hubs. You have the subsea facility here in Trondheim. And then in the Trondheimsfjord, you have the national test area for autonomous vessels and the actual aquaculture lab here at Frøya. And then in Ålesund, you have a data center where all the data from all these different hubs are processed and able to build decision support system for. There are also data hubs here in Trondheim and other places, but yeah, that is the official program. And the cool thing here is for the subsea facility, you have access to a lot of important industry in Norway. And then you also have an acoustic network that will stay in the water all the year. You have subsea charging, but you will also have your regular shipping traffic and other types of marine traffic going in the Trondheim fjord. So you're able to test in real life environments. So here you have a lab, which is also the field, which makes the test very much more interesting than we've seen before, instead of the controlled pools. And then you have the national test area for autonomous vessel. And when you're doing autonomous vessels, whether it's subsea, outer space, or oversea, you will always have the problem about what happens if our system gets attacked. So here you have VDAS, you have a lot of different sensor package, but you will also have, yeah, of course, you have radars, LoRaWAN, and other types of fast and slow network connection, depending on your needs. But you will also be able to test what happens if somebody tries to attack your vessel through cyber attacks. So you have digital twins and a lot of infrastructure to support this, because especially if you're doing mission-based robotics and not completely autonomous, there are a lot of things that can go wrong if you can take instructions from another place. So this is also very important to test for, which is why all of these data points are integrated, so you can do accurate logging, accurate tracing, and yeah, accurate analysis of your data. Then you have the aquaculture. Probably you're thinking, why would you talk about aquaculture in a robotics lecture for speaking about robotics? Well, the thing is, in aquaculture, as we've tried to test, there's a lot of data, right? You have this called, I'm not familiar with the English term, maybe smart mada is in Norwegian, but these fish growing aquaculture, aquaponie sites are very highly instrumented. They are dirty often. There are a lot of pollutants here, and there's a lot of things that you need to do to maintain, to fix, and then you have to navigate through fish, which requires you to create a pretty sophisticated robot to do so. So that is why these hubs might be of interest to those doing robotics. And then, of course, there's the wireless communication network that I briefly mentioned for connecting all of these hubs. I'm not going into too many details here, but there have been developed some new protocols that are available, of course, for everybody going here, because you want to be secure, you want to be fast, and you want to be able to support lower energy devices from very far away. For instance, we almost have a better connection to the Mars rover than we have to Svalbard. And just before wrapping up, because I see that my time is up, there's the marine observatory with a lot of different things for observing the water, and with a lot of different buoys, which are quite large, which are able to connect to your robots. You see the activities here. So thank you very much. That was a bit fast at the end.
Okay. Well, great. Well, did you have something? I gave you 3 minutes, so you were okay. But did you?
Oh, I'm sorry. I thought you.
No, it was 3 fingers. I thought I was. Yeah, but anyway, you just keep. You know, give 2 minutes more. We're good. Yeah.
Yeah. No, but so yeah. So what I wanted to talk about finally was that you're able to have these large buoys, which has a lot of different instruments, which you're able through the interconnected hubs to communicate with, so that you can serve as, for instance, you want to do. So let's take a practical example. For instance, for the extant life observer that NASA is planning to send, you might want to be able to follow chemical trails. And by connecting to these buoys, you can locate chemical trails, and you can send your missions to your robots to follow this. And you can see, or you can then see how they're functioning in field, by you have very accurate devices on these buoys, and you can see how your robot is interacting with the water, with the different chemical parameters, and so forth. This is, of course, have much bigger purpose than that, because it's supposed to support policy making with regards to local environments, see how thing functions while having a in situ observation model. But that is basically my presentation. So thank you.
All right. Well, thank you so much. Very interesting. Let's see. Let's turn on camera here. There we go. Okay. So let's see. Are there any questions, or are we going to have those coming up here? Let's see. Here we go. No. So we're just going to open up for questions now, which is totally perfectly fine. So if you have a question, you see Patty is on here, and she's a subsea expert. I see a lot of friendly and well-known friends here. So welcome to everybody, and feel free to ask questions now. Just chime in. Do you want to start, Patty, or since you're up, you're the only picture up here? Did you have a question, Patty?
I think she's muted.
Yeah, you're muted. So let's see if we can help you with that. I'm going to unmute you. There we go. Yeah, you're on now. You can talk. I guess we don't. Yeah, you're on. We don't hear you.
So you probably have the wrong microphone source on your GoToMeeting.
Most likely. Yeah, no, we don't hear you. Diving language. Okay. Yeah, you unmuted, but maybe we can get back to you. Try maybe to switch microphones. All right. Yeah. Well. Okay.
So yeah, so the Illume robots, if you're thinking about that one, or snake robots in general, are usually tethered. The reason for that are multifaceted. So it might be autonomous in the way that it's able to perform its duty without human intervention, but it does have a physical link, absolutely. You also do have a control room in case you need to actually send controls. So I guess it depends on how you define autonomous, but it's absolutely tethered, yeah.
Okay.
At least for now. But I think during the field test in Oscar, it's supposed to be untethered.
Patty, we don't hear you. Maybe you can write your question and we can read it up. That would be perfectly fine too.
But I see that in this meeting, there's actually someone who has way more hands experience than me with these snake robots, Eleni. So you can probably answer that even better than I.
Absolutely. There you go. Where is she?
Hi. How I can help? Hi guys, very nice presentation, Peter. What was the question? I can try to.
Whether the tethering on Illume, whether it needs to be tethered eventually. It has a physical link.
Current tested versions, they have used tethered in some,
yeah.
But the new versions of the Illume robot is completely autonomous with its own batteries. So it has also energy autonomy. And that's why it will have the docking station for charging when it's needed. So the latest version for the test that you mentioned, Peter, will be all fully autonomous energy and communication and everything.
Yeah. So that was the plan about the test in Q4 in Oscar. Then they are supposed to be untethered with a docking station for them to recharge their batteries.
Yeah, and also the test in Trondheim Fjorden that they have done with the docking station, they were also the untethered version.
Yeah. So the video I showed is from that, and then at that point they're untethered.
Yeah.
I got a question. In terms of the Oscar field experiment, it's very exciting. There's no doubt about that. How long is it planned to be living out there? Because that's always, when I think about living out on the installation, you just don't put it down for a day and say, okay, now we're done. Is it weeks or months, or what is the plan here?
So the plan is at least entire Q4, and if it's successful, it's supposed to live there.
Right. Okay. And what is?
So I guess the answer is we'll see.
Yeah.
That's the interesting part.
But how much maintenance do you need? I mean, how often? Because everything for electrical connectors might be getting well, it wouldn't obviously be dust, but mud or whatever material you find in the ocean on them. Is that the concern? Has that been looked into? Is that part of the experiment? I'm sure it is. But what are the considerations there?
So I don't think I can answer any very specific questions with regard to that. The pipe inspection is of course daily, so that is often.
Right.
But for the to remove dirt and dust, and I think that depends.
Sure.
I can't really answer it because it's you have to know the specific of the Oscar
Sure.
area. Yeah.
And how long does a charge last?
Eleni, do you know exactly?
At this moment, that there is no specific time in the sense that they're testing the capacities with the different batteries. So since it's a modular, depending on how many batteries you can put on the robot, you can increase also the energy. So this type of the snake robot, it has different modules, so you can connect different ones. So, but such technical questions, I think only the Illume company can provide. Regarding the previous question of how much it can stain all these things, all these tests that has done in the Trondheim fjord, they have stayed the robot for a long time to test, for instance, the pressures, for instance, how much it can stay, all this cable is handling, or the biofouling can grow around in the structures. So all these factors need to be tested, but only Illume can provide such detailed information, and I don't know even in which stage.
Sure.
Yeah, and it would be dangerous for us, I think, to try to speculate.
Sure. No, it's more if you knew, but this is good. Okay, it's those are quite exciting questions. Okay, so we got Jacob. Did you have a question? We need to unmute.
Yes. I think you had a talk earlier on about Jupiter moons.
Yes.
I don't know. Yes. So how does, if I can ask, how does you could apply this technology on Jupiter? Maybe send a robot there as the same as Perseverance and all these other robots that are exploring Mars at the current moment. That's just a curious question, but it's very important to talk about the Oscar field and how it's applied oil pipes as well. But thank you very much for the presentation and the answer.
Yeah, thank you. So with regards to exploration space, I think it's most applicable, a lot of the technology I talk about now, 2 things. For the icy moon explorations, the hydroacoustic and acoustic propagation there are extremely important, both for the moons where you have to bore, because you need to communicate through maybe 30 kilometers of ice, which is highly difficult, unsolved per now, but you're able to probably leverage the so the hypothesis is that you can leverage the knowledge that we have from hydroacoustic modeling, and hybrid systems with machine learning and mathematical model combined are able to more accurately be able to send data or transmit data through the different impurities of ice. The test that we've done in the Arctic with regards to RF in ice has also proven very successful and capable, but relay RF through multiple layers of ice is also, at least at the thickness at the moons, are very difficult and also per now unsolved, which is maybe you can have a combination there as well. And the snake robots, they are very interesting in the cases where you have crevasses. Let's say you have to navigate through a crevasse. How would you do that? What kind of the modularity of the snake robots allows scientific payloads to deploy before, in a way, you even start. So you can do autonomous operations or decision making to find crevasses. And once you start entering the crevasses, you can use your scientific payloads in the plumes, hopefully. And then you're able to navigate a snake robot places that other robots will have difficulties with. So there's a ESA-funded report about snake robots on Mars for cave exploration. So that's so there are some material there which are interesting. We're working on it. It's the best thing I can say. But there are absolutely applications there, or at least we think so.
Okay. Any other questions? Let's see. I'm going to send a message here to Patty.
So Gendi, is your question with regards to the Illume robot specifically, or other type? For instance, for Hugin, you can go about 6,000 meters for the torpedo-based AUVs. So that's a 6 kilometer step. For Illume, I don't think I should answer that question, because I think Illume company themselves should probably do that, because it's under continuous development right now. It's in multiple research projects, and since the commercialization hasn't started rollout, it will do that based on the how well it does in the field testing Oscar. Anything I might give you, depending on the earlier tests we've been involved in, might be inaccurate or wrong. So I should probably not say anything. I think that's the best answer.
Okay.
So deep sea minerals, well, there's a lot of different people who have a lot of different ambitions there. I myself haven't worked too much in that. So we've been working in classification, generic classification based on hydroacoustic payloads and synthetic aperture sonars. And I can say that the classification schemes are becoming way more sophisticated than they were just 5 years ago. But other than that, there is little I can provide about info about deep sea minerals. It's a part of the ocean space program, or at least it's mentioned there. Yeah. True ice operation, well, whether or not it's a focus area, it's difficult to say, because the focus area keeps moving. But what I can say for SINTEF Nord is that we're situated up in the high north due to the fact that we are closely located to the Arctic and other areas up north, and ice is something that we face very often. So we are working in different scenarios with true ice operations.
Thanks, Peter, and thanks for the presentation. Just to follow up on that, I was wondering as well if you've looked at acoustic mapping of the underside of the ice, if that's something you've looked at.
So yeah, there are multiple researchers who's looked into that, but that is mostly using, so we can only map the entire ice. Mapping underneath the ice from devices on top is not something that we've worked on. We worked on communication penetrating vertically and started horizontally, and there's been a lot of seismic research to map the entire ice, but then you face often bedrock or other things, and then your seismic system doesn't work. We hope to start a project in a couple of months with regards to true ice to water and the ice-water interface where you place slush.
Okay, thank you. Yeah, I'd be really interested in hearing more about that as it develops, and also really interested in hearing more about the RF through ice communications as well. We obviously have our reasons. I have my reasons for being interested in that, of course. For the future, Europa exploration, where you possibly don't have a ship on the, well, you definitely don't have a ship on the surface that can do the sounding for you. So the ability to do under ice mapping from a small compact platform is very interesting.
Right. Tom, feel free to turn on your camera, by the way.
Yeah, but we've done under ice mapping using AUVs. That is something that we worked on a lot. It's more challenging, of course, due to the reflective properties of ice, but it's doable. It is doable if you're underneath the ice, of course.
We got a question here from Patty. Let's see, and that was about charging. What do I have that? Let's see, please. Let's see, here we go. Yeah, what is the mechanism for charging underwater?
So Eleni answered that. It has a Blue Logic underwater docking station. That is at least what they use for the Illume robot in Trondheim for charging and etc. So I think Eleni is writing out the answers here.
Active charging. So I'm trying to put some information about Illume better, since it's quite specific question.
Yeah, it's specific and quite popular. I see. So yeah, I did send an email to some of the associates at Illume, but sadly they were too busy to be here, which is understandable, given that it's a very small company right now.
Sure. And we got one, let's see, Kevin, you also had a question here. Didn't I see that? Feel free to just unmute and ask the question.
เช่นสวยหากเอาลูกตานั้นออกไปเสียจะเป็นอย่างไรผมสวยก็ให้ผมหลุดหัวโล้นเป็นอย่างไรความสวยก็ให้
Oh, little hard to.
Sorry, I couldn't hear.
Kevin, it was a little hard to hear you actually. Can you try that again? Sorry.
จมูกรูปชมพู่จะเป็นอย่างไรแม้ดูร่างกายสุดสมสุดก็ให้มันใหญ่โตมโหฬารหรือผอมแห้งจะเป็นอย่างไรหรือลอกหนังเนื้อออกจนหมดเหลือแต่โครงกระดูกแล้วจะเป็นอย่างไรแม้อวัยวะเพศและแขนขาหากมันขาดด้วนหงิกงอผิดรูปไปขนาดมันใหญ่ไปเล็กไปจะเป็นอย่างไรเป็นต้นในอาการ32นี้หากมันขาดไปหรือไปเกินพอดีล้วนทำให้หมดความงามลงทันทีทั้งหมดล้วนเป็นอุบายในการปัดอารมณ์ราคะได้ทั้งสิ้นแต่จงอย่าลืมว่าให้ใช้อุบายนี้ด้วยนิมิตใช้ปัญญาเป็นนิมิตเห็นเท่านั้นอารมณ์ในนิมิตสมเด็จองค์ปฐมพระบิดาตรัสสอนไว้ดังนี้1
Okay, so if you're thinking about how long I've been working in this domain, I've started in with
บุคคล
acoustics
ผู้
and
เข้าถึงฌานก็มักจะใช้ฌานกดเก็บอารมณ์อันเป็นกิเลสนั้นๆหรือบางคนก็อาจจะกดด้วยการพิจารณาในวิปัสสนาญาณซึ่งยังมีกำลังอ่อนๆอยู่2
Kevin,
ตราบใดที่เราทำด้วยความเปิดใจไม่ได้กำหนดจิตให้อยู่ในฌานธรรมนิมิตก็จะปรากฏขึ้นมาทดแทนอารมณ์ของจิตให้รู้ถึงส่วนลึกๆของความปรารถนาของอารมณ์จิตว่าเป็นเช่นใดซึ่งเป็นปกตินิสัยของนักเจริญพระกรรมฐานจะต้องพบกับข้อสอบตลอดเวลาไม่ว่ายังหลับหรือยังตื่น
So I think we're going to have Peter just answer a question about how long. Peter, do you want to answer that question?
wait, sorry, it's harder to hear you.
ฉะนั้นจิตจะเคลียร์มีความเผลอได้ง่ายเราก็เช่นกันให้สังเกตดูให้ดีๆก่อนที่จะถึงจุดตั้งจิตคุณชาอนุสติใดอนุสติหนึ่งได้อย่างมั่นคงหรือวิปัสสนาภาวนาอยู่ได้ตลอดจนกระทั่งหลับอาการธรรมนิมิตก็จะทำให้นั้นไม่มี
I don't know what's going on. Let's see.
Okay. Thank you.
Yeah.
เกิดมีอารมณ์ฟุ้งซ่านนิวรณ์5เข้ามาแทรกอารมณ์ของจิตให้ออกนอกลู่นอกทางจากอารมณ์ของการเจริญพระกรรมฐานแล้วจิตปัดหลับในขณะนั้น
Okay. Yeah, I think we're going to have you answer that, Peter, and we'll take it from there.
Sure. I was just trying to figure out whether it's not been working on this domain. It's been since 2014, 14, I think. Yeah.
Okay. Anybody else? Bill, let's see. We have some pretty serious. Let's see. Bill, do you have any questions? Bill Neesmith?
I was thinking more in terms of how do you think we could do some cooperation as we try to develop these types of systems for future missions, particularly like Enceladus, where we have these eel types of technologies that are really required to get through the ice and to the oceans below?
Well, we are trying very hard to actually cooperate there. So what we started to do is we're starting with the get to know each other part of the research. So we have we are planning to submit a proposal to the Norwegian Research council, where NASA JPL would be a part of that. And then with regards to especially that mission, and we hope that we can contribute to your robots and vice versa, and then we're able to do researcher exchange, work on the same platforms in order to try to do things that can be beneficial both to outer space and ocean space here in Norway. So that is where we're at now, and that's where we're trying to start, I think. Yeah. So there are they're very interesting to see how people who send robots to outer space thinks versus how to rebuild them here. So I think it can be a very giving project to start with.
Peter, I think we also got a question about, what if one of the thrusters on these snakes fail? How is that going to impact the robot?
No, so the thrusters are in a way a support system. They have actuating joints as well, so they can do the snake movement. So as you can see in the one video I showed, it doesn't have any thrusters. Okay. If you're talking to the thrusters on the side. Yeah. I mean, So if one thruster dies, that's fine. The thrusters are there to add more or easier controls, so it can stand still and rotate around itself.
Oh, that's right.
So otherwise, it had to swim away and then come back.
Okay, so you can actually swim it without the thrusters. That's actually very important information. Okay. So the key of the thrusters is really, as you said, to have more torque if you need to do work, as opposed to...
Yeah, and they're also, they do provide more in-place movement.
Sure.
So if you're standing still and want to rotate around yourself, you have to have some sort of force coming from the outside, and thrusters can be that.
Right. But for example, if you are in Enceladus, you want to go in a crevasse, the thrusters might be a little hard to have. And if you want to go in...
Yeah, the thrusters is not used, wouldn't be needed.
Exactly. So you have the capability of this to move both in on surface, which you demonstrated also, as well as in water. Yeah, okay. Very interesting. Okay. So we can put this in a cave on Svalbard.
Yeah, hopefully. We'll try.
Yeah, exactly. Yeah.
So Jon Boring asks if there's any research for MHD propulsion for ROVs. What I would say is you should probably direct that question to Martin Ludvigsen at NTNU. I don't know, to be honest. Magnetic propulsion, right? MHD, I'm not too familiar with that. It's in, yeah. So sorry, can't really give you a good answer to that.
Okay, somebody else is trying to get on. Was that you, Patty?
Oh, yes. Am I on?
Yeah, you are.
Yes, you're on.
Oh, my goodness. Thank you. Well, I'm sorry, but you guys were muted for a while. I finally got it together here. So my question was regarding the charging underwater. And forgive me if you already answered it because I didn't hear it. What's the mechanism for that?
So they use the Blue Logic underwater docking station. So it's using induction to charge underwater. So it's a magnetic charging station.
And by the way, Peter, just for information, Patty, why don't you say 2 words about yourself? You're rather accomplished subsea person.
Well, over the years, I guess it added up, didn't it? So I'm a dive master. I've done some filming underwater, and I've had quite a few connections with the deep ocean people, such as Phil Newton with Newtco. And right now I'm starting a new job with coordinating expeditions for a phenomenally equipped dive boat in Malta with Triton submarines and the such.
Yep. So if somebody wants to go diving with her, that's not a bad idea.
Yes, we have 3,000. We have a 1,000 meter depth rating on the subs.
So yeah.
Interesting.
And where we go wherever the funding goes. So
Yeah,
certain the base right now is Malta, but we go wherever the funding goes.
Was a good philosophy. Okay, let's.
Yeah, but to answer the question specifically, it uses a two-way power delivery, data transfer and communication system through induction. So it's inductive connectors.
So it's connected though, right? You're connecting.
No, you don't have to connect that. It's a wireless standard.
Oh my gosh. Okay. That's amazing.
Yeah, it really is.
Yeah, so Eleni just shared a link to the docking station. Yeah.
Milan?
Do I see it?
What, sorry?
I think you should see it in the chat as the link furthest down.
Yeah.
Yeah, so that is the specific charging station, and Blue Logic is a part of the wireless standardization for underwater intervention drones, UIDs. So it's a popular one, and they're part of the SWIG subsea wireless group. So there's a standard interface. Yeah. So Krista Borgen, well, I shouldn't answer for NASA, seeing that there are multiple NASA people here. So maybe Knut or Bill or anyone else want to take this question?
Which was that?
Something about the timeline for the icy moon exploration, whether it's east or prime or yeah.
We're talking about the 30s, 40s. This is far out because first we're gonna take a vehicle there. For example, for Europa, we now have an orbiter that's going to explore it from an orbit. Then we're going to have a lander, and then hopefully we can have a robot that can go through the ice. So it's far out, but it is a very important part. And of course, all these missions before is going to help us plan these missions. We talked about the cryobot earlier. Jean-Pierre Florial talked about that. And for Europa, that is the mission we're envisioning there. For Enceladus, that could be a snake robot, or most likely a snake robot. We're also looking into that. That could be about the same time frame. We don't know, but that is the best we can say at this point. So let's see. Yeah, and I see also Tom added some information there. But yeah, there's a lot of discussions, a lot of groups working on this. Tom is also involved in that. So it's, but it's a moving target. It's a lot of politics involved, a lot of budgets that have to be approved. So we can only look at what technology can tell us what we can do, and with the missions before we get there to give an answer to that. So
yeah, and Knut, if I can add something there,
please do.
It's kind of I think it's a very exciting time to be having these conversations with colleagues in Norway, because there's a lot of push for creating something similar to the Mars exploration program, but focused on these ocean worlds and the other solar system. But it doesn't currently exist, and so right now is a really kind of exciting and formative time in terms of developing the concept for what a long-term strategic plan for ocean world exploration would be. On Mars, we've had this step-by-step program where we've had stationary landers, we've increased to robots with increasing capabilities. Whereas for right now for ocean worlds, we don't actually have a cohesive plan. And so it's really exciting right now to talk about what kind of technologies we would have available in something like the 2030s, 2040s timeframe, and what could actually be done. So, and just to say that I think these kind of conversations are really important and exciting to be having right now.
I agree, and thanks for bringing that up. And you said it indirectly, Tom, and we believe that Norway, with the capabilities of ice and snow from Svalbard to the northern Norway, people are used to these environments, deep pressure, great depths. Norway has a lot to offer when it comes to ocean world exploration, and therefore we're very excited to have communication, interaction with SINTEF, NTNU, and University of Oslo, etc., to see if we can involve them to the benefit of NASA and, of course, also Norway. So it's a lot of very interesting and exciting things that are going on, and these discussions will be going on. And I think, yeah, you sent an article, Tom, and there is more in terms of discussions going on. There are articles. We did discuss the different technologies in this series of Ocean Worlds in terms of the EELS project with Colin Carpenter. We had Jean-Pierre talking about the cryobot. We had you, Tom, talking about the buoy. So yes, there's a lot of interesting technologies. And if anybody's interested beyond this webinar, you should feel free to contact us. There is programs that are related to science technology at NTNU. There are programs at universities in the US. And if anybody on here feels that they want to pursue this route, the opportunities are pretty amazing. And it is, as Tom just mentioned, it is going on right now. If you want to get in on it, this is the right time. So having said that, I think I'm going to start closing this. And are there any more questions? If not, I'm going to say a few words to end this and also about what our plans are going forward. Any more questions?
If there's any more questions as well, you can just send them to me at this email.
Right, fantastic. And Milan, I see you.
I'll try to answer.
Glad to see you. We'll talk later. Let's see. Let me go back here. Let's see. Make presenter. There we go. Okay, so we are done with this. Thank you, everybody, for being part of it. Let's see. Here we go. Yes, we've done that. Now, we are actually in communication with the Mars helicopter people. A Norwegian, Håvard Grip, he was part of the guidance, navigation, and control system for the Mars helicopter. He is in the middle of the mission. We also talked to Tim Danham. He is the developer of a software program called F Prime they're using for the Mars helicopter. We are planning to have 2 webinars in what we call the Mars helicopter series, starting with an overview and then going into the software. This is a software that is freeware, shareware, and open source, and is being utilized a number of small projects, instruments, and has been already, as well as CubeSats, and we want to focus in on those. Now, the question here is, this may be in May, it may be in June, depends on how successful the Mars helicopter flights are. They're starting tomorrow, and I encourage everybody to actually go on the NASA site and get to see the flight. It will be broadcasted there to the extent possible because we're on Mars, but I really encourage you to do that. So we can't promise it's going to be May or June. You're really in the middle of a mission, so to speak. We're dependent on what is going on there, but it will be 2 webinars, and we will get back to you as soon as we can. I'm in communication with Håvard Grip, the Norwegian gentleman, and he's very eager to come and talk to us. So that's where we are on that. And with that, unless you, Francis or Tom, have anything to add, do you have anything to add, Tom or Francis?
No, look forward to the next one.
Okay, great. Thank you. And that was Francis, also a board member, Francis Mohajiri. So with that, I would say thank you very much to everybody, and we'll see you next time, and we'll get back to you very soon about that. And again, as always, this is the link, and I like everybody to open up the microphone so we can give Haro a big applause. Can you do that? Unmute all your microphones, and we give him a big applause. Try that. Well, not too bad. Okay, great. Thank you very much. Have a fabulous day.
Thank you.
My pleasure. Thank you. And till next time, we're looking forward to seeing you then. Bye-bye.
Bye-bye.
Thank you. Thank you.
Thanks.
Thank
Bye.
you.
Pleasure. Bye-bye.